Okay, I think you're good. Oh, yep. Yep.
And so, what I'm here, I'm going to speak about APacheCon, a bit about Kafka. So, let's begin. So, who I am? I'm Álvaro Santos. I work in Spain, Madrid. I've been working in cloud and big data projects for many, many years. So, I think I know. So, well, many people know about Kafka. Have been used for many, many years in many, many companies. There are some of the very big companies with me. Of course, there is LinkedIn. So, why should we use APacheCon? I think you should know before knowing what. Okay. So, first thing, because I'm fucking curious. So, I have been searching for new projects. Most of them in Apache Foundation. Very things here. In Linux Foundation is making a good good right now. Second, learning about good. I've been studying new technologies. I have 4 or 5 certifications in cloud. So it's all good. And the third thing is, could we know better? I've been using Apache Kafka. I suppose most of you know Kafka. I suppose very probably those are a bit less. But I want to know that Pulsar could do it better because I know the limitation of Kafka. So I try and I found Apache Pulsar some years ago. Okay, so let's do it. First, what's the Apache Pulsar? It's an open source distributed message system created by Yahoo. We have 2 guys here in the front that could say more things. As a message system is where I've been using it for the couple things in microservices, in streaming solution for the data, and many, many other things. Okay? So we can create very powerful architecture, event-driven, of course. Some of the features. First thing I think is open scalable. We can create very big clusters of Apache Pulsar, like Kafka. Second, low latency. This is very important. I'm going to explain why here in the IoT room is very important. Multi-tenancy. We can use the same cluster for many applications, and we don't have to create new cluster in the region. Persistent storage. A good thing about Pulsar is to use another solution for making the things that they are not used to do. So it's quite good. First thing, Pulsar Fusion. I know that Pulsar Fusion was there when I first met Apache Pulsar. It's quite good. We don't have this in Apache Kafka. Other things there, but function not there. And the replication. Many companies, I have watched a lot of talks from Netflix saying about all the things that they are suffering from replication in their regions. So I think this is quite good. Okay. So we're using Pulsar, of course, Yahoo. The was creator, apparent from Hadoop, more than 80 tenants, more than 2 million topics, a lot of million messages per day, and replication. So here in IoT, why we should use Apache Pulsar? In IoT, we have many headaches. The first one is latency. The other one, volume. Streaming is a very hard problem. Volume is too difficult. The organizing factor. We have devices in every place in the world, so we have to start with this thing. And finally, exponential cost. Okay. So if not done thoroughly, we can have very big. So what Pulsar would give us? The first one is low latency. It's ready to serve. We have less than 5 milliseconds from reading from the server. I think this is because some of the trailing rates. I'm not going to explain it, but I think this is very important because it's quite fast. It grows with volume. It's horizontal and scalable because the processing is separated from the storage. This is quite good. The one is global architecture, multi-tenancy, clarification, many other things. And finally, is component cost. We have some features that we can use in order to decrease the cost. One is the functions, and the other one is cloud friendly. I've been using Apache Kafka and have explored a lot with the installation. And I'm going to explain in a demo later. I have started with help in a Kubernetes cluster. This is quite awesome. Okay? So a little bit about architecture. As I said, we have separated into different layers. The storage layer, which use Apache Bookkeeper. This is another project. The Apache Foundation is especially done for storing data in a distributed way. So Apache Pulsar doesn't have to know how to do it. So they can do the processing part very well. The programmer doesn't have to know how it's done. Okay? And this is done by the broker. Okay? A cluster topology is very simple. We have the Pulsar broker who receives the request, reading and writing. The bookkeeper, the cookies, are the servers who store the data. As many projects in the Apache Foundation, we use Zookeeper for storing the configuration and manage the cluster things. We connect using a typical DNS. So which are the Pulsar brokers? I've said before, is a stateless component, so we can scale it very fast. For example, in Kubernetes using containers. So they doesn't have to know what is happening. It's a simple HTTP server, so very fast. And also we can use a TCP server. Bookkeeper, said before, is the service that stores the data. There is a write-ahead log using WAL. So it's crucial in this architecture because it's a replicated log storage like Kafka. It also writes very fast. The one is the consistency. It has it's highly available. A lot of Bluetooth and IO isolation. The other part is the metadata store. We use Apache Reaper for storing the metadata about the cluster configuration, the coordination, for knowing which is the master in the cookies and other things. Okay. And how it works. Well, as I said before, it's a multi-layer architecture. In other servers, streaming solutions, we have a monolithic one, and we have all the same server for serving and storage. In Pulsar is totally different. We have these servers that are separated for the storage. This is done by the writes. Well, this is very simple. The brokers are serverless servers, like stateless servers, so we can increase the number of servers very fast. So all the clients connect to the Pulsar servers, to the brokers, and they will coordinate and go to Bookkeeper to store the data, and then it will come the response to the reads. We have two different types of reads, chain reads and catch-up reads. The first one are very fast. So this first one are used when the data is very busy. So Apache Pulsar have a catch in the memory. So when a request receives and it's very so you can return the data very fast, or they can change that. And we have the other one, like catch-up reads. That's, for example, for systems that want to know for the first time, and it's for storage. Some systems require it, but other one is not necessary. For example, if you want to know only to count in what is happening every minute, we only use the first one. Some concepts in Apache Pulsar message is the basic unit. We send message. The producer, basically the system to publish message topics. Consumers are the system that read this message and send acknowledge to the system when they have complete process. Namespace is a logical nomenclature which allow to hierarchically manage the topics. And finally, topics are the channels in which we transmit the message. We have a very simple name. We can store persistent or not persistent name. That's in memory, the tenant, the namespace, and the memory. Well, one good thing about Pulsar that we have different things for streaming. This is quite good. In Apache Kafka, we have, I think, only one way. In Apache Pulsar, we have different ones. We have the streaming and we have streaming. In Amazon, for example, we have different solutions for this streaming. We can do at the same time. Streaming, the third one is exclusive subscriptions. This one, only a single customer is allowed to access to the subscription, so one consumer is reading at the same time. So if one consumer tries to read for the topic, it's going to receive an email. This is the streaming typical use case. Also, available subscription. So instead of sending an error, if the consumer is failing, we can send to the next consumer when something fails. But this with Pulsar, we don't have this. We have to wait with the client, it's very tricky and sometimes working. And we depend on a few people. In Pulsar, it's out of the box. Okay. The second use case is keeping. So we have different consumers reading at the same time on the same subscription or topic. So we can process much faster because we have different consumers. The way of doing this for Apache Pulsar is a round robin distribution. So randomly, the message will be sent to the consumer. When a consumer is correct, all the message that were processed or were from that consumer will be sent to the other consumer. So they can.
So is there a way to do this packaging with message distribution from non-robin to something else?
I don't think so. Yes, but
Yes.
thank you. Another quick feature about Pulsar in the schema registry. This is quite awesome. So we can store in Apache Pulsar how the data is. We have this now in Kafka, but it's not from the first time. So we can store how the data is being received, so the consumer will know what they are going to receive. It's quite good. We can have the metadata about the name of the topic, the binary representation of the data, the message, the schema type, and some properties that the user can put in the topic. Okay. Well, another feature is the push function. We can upload simple and very powerful scripts into Apache Pulsar, so we can make transformation, make whatever we want. I'm going to show you later in the demo. This is out of the box. You just send a command to the Apache Pulsar, and they will be executing this transformation. So why we want this? Because this make a very powerful but simple logic very fast. You don't have to create an streaming application, Apache Spark, for example, upload to the server, to the cluster. This is very slow. In Apache Pulsar, you have a very simple Python script, upload, and it's executed. No problems. Pulsar.io. This is a way of connecting Apache Pulsar with the world. So we have two different ways. The first one is the source. We want to ingest data in Pulsar. And the other one is sinks. So when we have make some processes or other ways, we can send data to very common data stores like databases or other topics in Apache Pulsar, other streaming solutions. Another feature quite good is the error replication. This is very useful. We have different tenants in our Apache Pulsar cluster, and it automatically will be replicating the data in every cluster, so we don't have to worry about how it's done. I don't try it, but I think it's quite good, at least for every contact. My customer typically works only one region, but the big ones, for example, Netflix, are only when they need. And this is what we got here. Why? that right now have very demanding requirements in IoT, have low latency. In Kafka, we have a limitation about the number of topics. In Apache Pulsar, we can have million topics. We have requirement of reliability, the replication, shared the scalability with Kafka topics. So we have to make approaches using the same topic. For example, in IoT, out of devices, we can create one topic for that device, so it's separated. But in Kafka, it's impossible. You have to manage with the key, with the metadata, so that in Pulsar, you can do it. The third one is about configuration, deployment, management. Apache Kafka, for example, doesn't have a way of deploying in Kubernetes. In Apache Pulsar, I'm going to show you later, you have in the GitHub repo help for doing it. In Kafka, you have to pay Confluence, have to see other projects from other persons. It's working, but not so well. Okay? Pulsar will have it. And the other one is that there is no support about the position. Well, this is a very good one. I've been working with Apache Spark streaming projects, so you have to worry about storing the point in time where you are doing in that time in Pulsar. So some technical differences about Kafka and Pulsar. Kafka is only a producer topic consumer and good consumer streaming solution. Pulsar is producer topic subscription consumer. The third one, Kafka is focused on streaming, exclusively on partition, and with Pulsar, we have different models. We can use it for streaming or using a key. In Kafka, we don't have that. Another thing is about the replication period. In Apache Kafka, we have a property that says when this topic is going to expire. In Pulsar, we don't have that limitation. That means that we don't have a TTL feature. In Pulsar, we have it. So we can specify when it's going to expire.
So when you say we support message TTL, so what if the message which is being sent to the topic are with different TTL times, TTL times? So, and the message which have sent before, I would say a much longer TTL. Whereas the message which is sent recently having shorter TTL. And if the message is not consumed, the older messages, does the new messages after TTL will be expired or?
I think so. A very big comparison. Apache Pulsar is very feature-rich. We have a lot of things: multi-tenancy, ACL, replication, scattering million topics, unification of streaming and streaming. Apache Kafka is more mature. We have Kafka Stream, Kafka Connect, other things. It's much simpler, but also less power, I think. Finally, I'm gonna make a small demo. It's very fast. I'm gonna show you how to run this in Kubernetes. It's called Cube here in my computer. So I'm gonna run some very simple commands. So first thing, just to show you how to launch a cluster very fast. This is a full cluster, not only a Docker. I'm gonna show you, but with this command, that's all. Just wait. So it seems not. Here you can see what are the containers that are going to do next. We have here we have different pods that we are doing right. We have the Jupyter cluster. This pod is, I think, for starting the configuration. Next one is the broker. The tools are servers. We have the Jupyter. We have some out of the box metric system. I'm going to show you quite powerful. Quite good. You can know the status of the server. A bastion pod just interact to the open. Fine. Next thing, I'm going to show you the tools of that one. It's a very simple dashboard, and knowing what is happening out of the box, as I said before, Kafka doesn't have it. So we can see the function, the different tenants, the different brokers, the topics, the status of the cluster. Continue. Your path. Quite good. Ahora vamos a los dashboards with different metrics. On the repeater, for example, different metrics. The pulsar for the VPN spacing topics. Next thing, to maintain server. I'm gonna create a namespace in the demo. Create the namespace for our streaming demo. Skip this. I have created a very simple producer in a Docker. The Docker. Now, our producer will be made that with the cluster. Let's see. You want it? Some message. What I'm going to show you now, a very simple function script who is going to transform the data. These messages are simple transactions about use case. So I'm gonna split them in other topics using in a Python. Okay. So I'm going to show you that the project script very simple. Here, import, duplicate, and send data. For loop, and send data. Now for the server. This is a example of function. We just create it from this class and make the project. Okay. In this case, I'm gonna separate between transaction in dollars and in euros and send to different addresses. Now we can launch a function. So, well, in this case, I'm gonna use the version host of the Kubernetes cluster. Load the files. Okay. How to start? We have a configuration file that says this thing. Very simple. And to install the function, this one. Very simple, very fast. Like this. That's it. It's running right now. No. 30 seconds, 50 seconds. No. Just run. Just run it. Another consumer. Yeah. In this case, it's going to read the dollar topic. So we have only a topic in dollar. This topic now. Yeah. So as you can see, this is very fast. In Kappa, you have to do a lot of things. In APacheCon, very simple. We have in Kubernetes, that is so cool. And that's all. Thank you very much. Thank you very much for coming here. I hope you know something more. And if you have some questions, I'm going to try to answer them. Of course, I have in my GitHub account this simple demo. I've been getting all of APacheCon, a very good one blog about the creator. This company, like the conference company, these two guys work there, so they know a lot about this. That's all. Some questions? Yeah.
What are the use cases or adoption you see?
I think that more startups, because they have more, you know how they work, like the big company work. They are very tight to the big companies who have Kafka in this one. I think there are some startups there that are trying to new other initiatives. Right now, I don't have any customer that's going to try it at least because there are banks, insurance companies, telcos. It's very difficult for me to say, oh, hi, I'm going to, I have this one, it's very good, very powerful, but they don't have, well, still you have support, but not from telco. So, simulation, we have a lot of projects that are competitors doing the same thing. This is a very good way of improving things, but we have this one. Some of them are very good at it, other ones not. But it's always good to try. If I don't know how to try what to do that, I encourage you to do it. So that's all. Thank you. Thank you very much. No, don't worry. Don't worry.
Oh, never mind.
Oh yeah, these ones don't work out. I just piggyback on this one. So we're running into the same problems. Also, traction. You know, Kafka's $1.04, it's established one in all the marketing pipelines. Nobody wants to be the first one to try the new technology. They all start doing things. Services.
For example, in the it's a lot of have to work with the client and kind of approach that doesn't work.
Right. Yeah. We've seen good stuff for financial services one through application, the real-time distributed system across the globe. Applying to the data is the same, right? You can do it on common. You can have that see it. We work with evaluate our stuff a little bit, but there's sort of, it's the ego. They want to write themselves, that sort of thing. So it's targeted and sort of about, sometimes. Yeah. We,
for example, with the people, they have the leverage for the microservice, the scenario,
yeah, it's, that was, sometimes, it's definitely something we're working on. It's the part of it that we're going to take one of these.
at least I'm gonna try my role. Just to you can try it.
POC.
Companies support
Because they want somebody to blame, right? So that's why companies like us come in and support. It's like if something goes down, they'll have experts on house to see if it goes all good. Yeah, but that's the thing you don't want to pay. Both down and balance.
at least for the
Or just a small, just a startup inside. A lot, but all
those people doing that. I don't know how many people, but 100 people,
Confluent,
100 people,
Confluent, for example, is going to have 1,000. They're about 700. But they're important. sales staff, support, everybody there teams by like
But it's like, they have bankers there, and it's for free.
and other people offer too. So I work with working here to get off that too. That was part of our nightlife. Platforms that is switched to a next year had all the problems. Big process again. Let's do this. But yeah, you're just market. Three different companies going high, singing the same song. But the ones that also it's that uphill climb. But it's a better thing. I looked at it. It looks pretty cool.
Right now, go on.
Well,
We
have a no function support coming out this month. A big microservices all go. There's some open source ones we're going to create a solid run.
Kai, what's your Twitter handle?
Sorry?
What's your Twitter handle? You have Twitter?
Yes, it's my name. My first and last name is Kai Reno.
Just one word?
Yes.
Customer is everything.
Others have trouble with the project before?
No, but I'll go help real quick. Let me just tweet that. And let's see what we got.
I really
I do. That's even weirder. Yes. But
That's probably not a problem on my Mac.
whatever, I'm just gonna call AB. What rocks 8? Hi, this is Trevor. I'm running the track down the Cox 8. Well, no, we plugged in the computer, but it's going on the side screen, but it won't go on the center. It's going both the side screens, actually, just not the center. Well, I just called AV.
Do we also have a microphone?
Projected voice. It's got good acoustics. We're recording there, and then also.
I mean, it's just for the people there. It was really hard.
Yeah.
I mean, this guy didn't speak loud. Right?
Yeah. It's playing on the side screen, not the center one, and it just worked on the last one. But we are. Yeah, when you start, well, we'll introduce you to the people that come up.
Yeah.
So it's
I
kinda neat to
mean,
see.
I can speak a little bit louder than this guy. But...
Yeah.
Right now. Still getting yellow screen.
Yeah.
No, we had to go grab some other copies.
Well, that's what I'm saying. Because no one's really watching on the edge of the flight. So if you pull one of those, that's fine. Yeah.
You want to say no one's doing on the side?
Yeah, let's see if that works.
Are you shooting from? Are you doing 720?
What's that?
It's 160. Oh, see,
Swap it.
Yeah,
this was coming down
I just
anyway.
picked in the
20 seconds.
Coming down here anyway. Did you get anybody?
I did. Oh, I don't know if they can say who it was, but I'm gonna go grab some water.
Yeah, I need something.
Okay. Well, okay.
Yeah. If it's still there, maybe that we can.
Yeah.
Grab. Alvin. Did you really need him to walk up over here? Any streamlines? No. You didn't want to go on the walk up. No, did you go up in the Go up to Savoy walk up. Just in case. Or I just came out.
Okay. You want to issue mine?
Just in
Yeah,
case.
we'll
I'll try to connect it.
I think standby is still.
Still warm down.
Yeah.
Give it a minute. Did it just do that?
I'm sorry.
Did it just do yellow screen?
Yeah, the last. Well, it looks like it's working.
No, it's
The last person was up, and theirs was fine on this one. He plugged his laptop out, and it's got plugged in.
Is it projector?
Yeah.
Okay, here we go.
Well, that's fine. That one is what I mean. Nobody's over there, and we're actually going to tell these people to come over to the center too, because we've got no mics. So, all right, looks like we're good.
Is this one like this and yours? That's your laptop, right?
Yes.
Do your cursor?
Looks like you're getting some of your edges cut.
Is it like that on your?
No, there should be
The left side is missing.
Yeah.
What's your? Yeah.
This one is working. No, only this one.
Okay.
Alan, thank you, sir. You fixed it already before I got here.
It's that projector.
Yeah, we just want to send it over. No, it's better. Now it's good.
Mark, is that one of the ones we got from
Yes.
next door?
Yes.
Okay.
Unfortunately.
Yeah, there's. I don't think for today at least there's any immediate need to get that. Nobody's sitting over here. We're trying to make everyone like come to the